So this next chapter is going to be on triangles, and the next coming chapter is also going to be on triangles, and the chapter after that. So we're going to talk about triangle basics so that we can understand how triangles work, and we can apply these properties and rules to future chapters. So let's go back and just define what a triangle was. A triangle is basically a three-sided polygon formed by three non-collinear points connected by segments, or what we call sides. Okay, so remember, non-collinear are not on the same line. Like if I draw 3 points like that, that is collinear. But if I draw 3 points that you cannot draw a line through them, that's non-collinear. Okay, and once we connect those points, we get a triangle. Okay, and in order to name a triangle, we're going to have to name the vertices. So for example, if I call that vertex on there A, I call that vertex up there B, and then I call the last one C, which is going to use the first 3 letters of the alphabet to keep it simple. We can call this triangle ABC. Now you don't have to write the whole word triangle out. You can just draw a triangle like that, and it's going to be the short version. So anytime you see a triangle like that, you do want to put the 3 letters after it so that we know which triangle you're talking about. Alright, we're going to talk about how to name triangles correctly. So we can name triangles based off the measure of their angles, or the distance or the length of their sides. For example, if you give it any triangle, if we look at the sides, we can call it by its sides, or if we look at the angle measures there, they're also going to have specific names based off their angles. Alright, so when we're classifying triangles by sides, we're going to name them by sides. We have 3 options. Okay, one of them is a scalene triangle. Anytime you see the word scalene, is that we're going to have a triangle with no congruent sides. And so for example, that side is going to be a different size than that one. So we're going to use 1 mark and 2 marks so that we can say they're not equal. And the third side, we're going to put 3 marks to signify that none of these sides are equal. The next one is going to be an isosceles. An isosceles triangle has 2 sides that are congruent. For example, those 2 sides are congruent. We're going to put 1 mark and 1 mark to signify that they're equal. But the third side is going to be a different size, so we're going to put 2 marks instead of 1. And the last one is an equilateral triangle. An equilateral triangle, we talked about this before, but equi means equal, lateral means sides, and so basically all sides have to be congruent. And so we can say, hey, all these 3 sides are equal, and we're going to put 1 mark on each one of them to signify or to notate that all sides are congruent. To classify triangles by its angles, we're going to look at the angle measures. Okay? Now, an acute triangle, remember, acute angle is angles that measure less than 90. Okay? So if the triangle has all angles that are acute, then that means it's going to be an acute triangle, meaning that that angle on the left is less than 90, the angle on the right is less than 90,
and the angle on the top is also going to be less than 90.
For a right triangle, it has to have one and only one right angle. For example, that one right there, we could say it's 90 by putting the box. You can also put the number 90, but a box is probably the easier way, okay? And the way you're going to see it the most of the times. And for an obtuse triangle, it has to have only one obtuse angle.
For example, that angle right there is going to be more than 90.
But remember, it also has to be less than 180. But it's going to be obtuse, more than 90 degrees. And it has to have only one. Okay, the other 2 here are going to be acute angles. And the last one is equiangular. Remember, equi means equal, angular is angle. But if it has all equal angles or all congruent angles, then it's going to be an equiangular triangle. And so we can signify that the angles are equal by putting those 2 little marks right there. Alright, so now let's practice on classifying or naming triangles by its sides and its angles. Alright, so if we look at the sides first, notice that all these sides are all different because it has 1 mark, 2 marks, and 3 marks. So therefore, when no sides are equal, we're going to call it scalene. And then now let's look at the angles. If you notice that these 2 are acute, and this other one is a right angle. So if it has only 1 right angle, we're going to call it a right triangle. And so if you put them together, the most specific name for this triangle is a scalene right triangle. For the second example, notice that 2 sides are equal, and if 2 sides are equal, we're going to call that a scalene triangle. But if I also look at the angles, We have two acute and one obtuse, and if it has exactly one obtuse, we're going to call it an obtuse triangle. So if we name it based off the sides and the angle, it's a scalene obtuse triangle. And the last one here, notice that all three sides are equal and all three angles are equal. So because all three sides are equal, we call that an equilateral triangle. But because all angles are equal, we also call that equiangular triangle. And so it's an equilateral equiangular triangle. Okay. Now a little bit of review. If you remember before, when a triangle or when any polygon is equilateral and equiangular, we can also call this one a regular triangle. Okay. So just by according to what we learn, it's equilateral and equiangular, but if it's both of them combined, then it becomes a regular triangle. Alright, now here's one of the most important theorems that you're going to be using for this whole chapter, and also in other chapters as a triangle. Okay. The triangle sum theorem is one that you have to memorize and you have to know for the rest of the year, and it's one theorem that a lot of people remember even after high school. I remember this one for a long time after high school, but it says that the interior angles of a triangle sum up to 180. Okay, now if you remember, interior is like inside, and the word sum means that you have to add them all up. Okay, so basically it's saying that if I were to add up all the three angles, angle A, B, and C, that it adds up to 180. But I'm going to show you an animation that's going to kind of show you how this works. And if I get all these three angles in the inside and kind of measure them, for example, that green one, that red one, and that blue one, okay? If I get all those three angles, and they should add up to 180, okay? And if you remember correctly, a 180 degree angle is going to make a straight line. So if I were to put all these three angles adjacent to each other, they should be make half a circle, which is 180, or basically the angle should make a straight line. Okay. For example, I'm going to move that green one like so. Okay. Now that green one is acute by itself, so it's not 180 yet. But if I put the red one next to it, now together combined, okay, this whole angle here is obtuse, so it's more than 90, but it's still not 180. And if I use the last one there, that blue one, okay, you'll see that all three angles make half a circle, the other half being down here, okay? And all three of those angles are going to equal to 180, okay? So when I add angle A plus angle B plus angle C, all of them together should sum up or add up to 180. Now that we know that stuff, now we can answer real life questions, like how much degrees is the measure of Phineas's triangular head. So now we know that his head measures 180 if you were to add up all the angles of his head. And Phineas is a very bright person, and hopefully you guys can be as bright as Phineas when you guys grow up, but you have to learn how to do your math. Here's a clip that I love from Phineas and Ferb.
How many jelly beans in the jar?
Oh, I am really good at solving these kinds of problems.
So the face of the jar is pi times radius squared?
You are measuring the radius in centimeters, right?
No, inches. That way the inch fractions work with pi as 22/7.
You do not use 3.14 for pi?
Oh, for crying out loud! There, 0.
Okay, technically, that is correct. But you did not show your work.
I will in about 20 minutes.
So now we're going to find angle measures, and we're going to do algebra and stuff like that to figure out values of x. For example, on this first one, it says find the value of x. Okay. So what do we know? We know that when I add x plus 100 plus 50, all three angles have to add up to 180. Doing my algebra, I can combine like terms on the left side, and 100 plus 50 is 150, and I get x plus 150 equals 180. And how can I move this number here with the other number, which are like terms? I can subtract 150. You guys know the rest. This stuff should be cake to you guys already. And I get that x equals 230. Okay, and so that's the value of x. Moving on to the second example, it says find x and then find the measure of all the angles. Okay, so make sure that you guys are reading the directions. Sometimes they just want you to find x, but sometimes you have to plug it back in. In this case, we're going to have to plug it back in to figure out the measure of this angle, and so on and so on. Okay, and so once again, 5x plus this angle 6x plus the last angle 15x plus 24, all that has to add up to 180. Okay, now we do the algebra, and if I combine like terms, 5x plus 6x right there will be 11x, and 11x plus 15x will give us 26x. And then we're going to add, or sorry, bring down the 24 and bring down the 180. Now we're going to subtract 24 from both sides. This will cancel. What are we left with? We're left with 26x equals to 180 minus 24 is going to be 156. Then if we divide both sides by 26, we're going to get an answer of x equals to 6. Okay, and that's what x is. Once again, we have to find the measure of all the angles. So if I go back and I plug in 6 right here, 5 times 6 will tell me that this angle is 30. If I plug it in here, 6 times 6, the angle will be 36 degrees. And if I plug it in here, 15 times 6 is 90. And 90 plus 24 is going to be 114. Okay, and you can also add these up, and it should tell you that 30 plus 36 plus 114 is going to equal to 180. All right, now we're going to piggyback off that last theorem we talked about, and we're going to talk about this theorem here. The acute angles of a right triangle theorem says that the acute angles of a right triangle are going to be complementary. Okay. Now, if you notice, this is your 90-degree angle there, and angle B is acute and angle C is acute. And if you remember, complementary means two angles that add up to 90. Okay, so what this is saying is that angle B and angle C are going to add up to 90 degrees. And here's a quick proof. Okay, well, we already said that angle A plus angle B plus angle C equals to 180. And we know that angle A is 90, so I can take that off and put 90 there. And if I solve for, or if I get this one and bring it over here with the 180, okay, by subtracting 90 from the left and from the right, what's going to happen is 90's cancel, and what are we left with? We're left with the measure of angle B plus the measure of angle C equals 2, and then 180 minus 90 is 90. Okay? So that's what the theorem is saying, that if I were to get this angle here and this angle there, that they're going to add up to 90. Now, you don't have to know this theorem. I mean, if you want to use the triangle sum theorem, and you can say, hey, I'm going to set it up this way all the time. You can, okay? But this is just a shortcut, that if I have a right triangle, you don't have to do all the angles add up to 180. You can just do that these two add up to 90. But most likely you're going to forget this, but do not forget the triangle sum theorem. Now let's go over the exterior angles. Okay? So the exterior angles of a triangle are the ones on the outside. And the ones on the outside, you really don't see them. Okay? But an exterior angle of a triangle is going to be an angle that forms a linear pair with an interior angle. Okay? For example, here's my angle, my triangle, sorry. And you'll see that the angles here on the inside, you can see them perfectly, okay? But there's no angle on the outside. So what we're going to do is we're going to draw a linear pair. Now if you remember, a linear pair is like if I have an angle like that, I have to draw another angle going like that. So that these two make a line, and together they will be 180, okay? So all you have to do is extend one of the sides. For example, if I extend the bottom side to the left there, you can see that that is your exterior angle. And why? Because together, that one and that one, the interior and the exterior, they form a linear pair. Okay, and you can do other ways, but just remember, if you just extend one of the sides that way, it is not the one up here, okay? Because that's not a linear pair, that's a straight angle. But this one right there is a linear pair with the inside. So this is an exterior angle, and that's an exterior angle, and so on and so on. Okay, so here is the last theorem. The exterior angle theorem says that the measure of an exterior angle of a triangle is equal to the sum of the two non-adjacent interior angles. Now, if you remember, adjacent means kind of next to. So non-adjacent is not next to it. Okay. So there's three angles here. Okay. And if you notice that angle C right there is adjacent, interior, and adjacent to x. Okay. So what this theorem says is it has to be the two non-adjacent. Okay. So B is not next to angle x, and A is not next to angle x. And it's saying that if we were to add A plus B, that it should be exactly the same size as angle x. I'm going to give you a proof here. And so sometimes you might be saying, well, how do you know? Or you're just teaching me the rules, but I don't know how it works. Okay, but I'm going to show you how it works because I'm cool like that. Okay, just to say we have a triangle like this, and I extend the bottom side so that I have this exterior angle x. And now what I'm going to do is I'm going to call the inside angles angle A, angle B, and angle C. And what we learned earlier is that angle A, B, and C together have to add up to 180. And what do we know about this angle C and this angle X? Well, that makes a linear pair, and together angle C plus angle X also is 180. Now, what I'm going to do is, if you notice that both of these equations have a C in common, and I'm going to do is I'm going to get rid of that C so I can bring it to the right side. You're going to see what's going to happen in a little bit. But if I subtract C from both sides, the C's will cancel. And what am I left with? I'm left with A plus B is equal to 180 minus C. Now if I do the same thing on the right side, and I subtract C from both sides, the C's will cancel. And what am I left with? I'm left with X by itself is equal to 180 minus C. Now notice that these both have 180 minus C. And 180 minus C is equal to A plus B. And at the same time, this 180 minus C is also, right there, 180 minus C is also equal to X. So I can say that 180 minus C is also equal to X. And if all three of these are equal, by the transitive property, A plus B has to equal to X. And we have proven that A plus B, or angle A plus angle B, their measures are equal to the outside exterior angle. Let's do an example. Okay. For example number 3 here, once again I have X on the outside here, that's your exterior angle, and according to the theorem it says that the exterior angle is equal, X is equal to the two non-adjacent interior angles. I mean, this one is adjacent, we're not going to use that one, but these two are the non-adjacent, and when you sum them up they should equal to the outside angle. Okay. So in this case X is equal to, and if I combine like terms here, 110 plus 35 is going to be 145. On the right side here, same thing. Once again, the angle on the outside, 5x plus 45, is equal to the sum of the two non-adjacent interior angles. This one is adjacent, we don't care about that one. And so we're going to do the two non-adjacent, 2x plus, and this one's 90. That's going to give us the angle on the outside. And if I set it up that way, and I can just do my algebra. Okay, once again, how can I bring this 2x over here? I need to subtract it to bring it with the like term on the other side. So that this cancels. 5x minus 2x is 3x. And then bring down the plus 45, bring down the equals, bring down the 90. Now how can I bring this number with the like term over here with the 90? I can subtract it as well. This cancels. And then I get that 3x is equal to 90 minus 45 is 45. And then I can get rid of the 3 by dividing by 3, and I get that x equals to 15. Okay. Now make sure you read the directions, find the measure of the exterior angle. And so if I want to find the measure of this angle, I need to plug in 15 right there for x. And 5 times 15 plus 45 is going to be 120 degrees. Okay, and so that angle outside right here is 120 degrees. You could have also plugged in 15 here. 2 times 15 is 30. And 30 plus 90 is 120 combined. and we know that this is also going to be the same as both of those, or the sum of those two.